We're comparing two illnesses, Gulf War and chronic fatigue syndrome. They have very similar presentations, and they're equally complex. If you map, network map, this is when you say, okay, there's this gene path, and there's this gene path. Are they talking to each other? And how many genes do I have to work through? How many pathways do I have to work through before these two are communicating with each other? So this is really cool because it takes in what's working correctly as well as what's working incorrectly into the analysis. And when you see a normal person, you see a spider web of communication. Average length 10, average number of pathways 3. So it's like, yeah, you can sort of see through that, right? With Gulf War, there's so many pathways engaged, you can't even look at it, right? You can't see through that. It's a huge number of upregulated pathways. Chronic fatigue syndrome, there's no talking. Everything's shut down. There's no communication between anybody. So big surprise that instead of seeing with inflammation upregulated, that the anti-inflammatory pathways should then upregulate, they fail. You don't get a cortisol bump after inflammation. It turns off, it doesn't turn on. So this is like opposite land, right? They aren't the same, but they present very similarly. So we get back to what we're doing. We're saying, okay, in healthy people, here's the endocrine system, the immune system, the autonomic nervous system, all the neuropeptides all playing together. I have a cold right now, so I'm not right there. I'm like right here. But when I'm done, I would hope I would bounce back to my old spot. But if you had something happen that brought you up over the mountain and dropped you into this new spot, this is your balance. And you can't go back here. It's not a straight line. You have to climb the mountain to get back. And so when we do the mathematical modeling of how to get back, it's never a straight line. It's all about how do you perturbate the system enough it has to find a new steady state. And then how do you shove it in a steady state way that drives it back. One such study, this is in Gulf War illness. I say that because we're really far along. Let's just say we're really well funded in Gulf War illness. And we have been able to take the virtual modeling through both cell models and animal models all the way to human clinical trial because we had the funding mechanisms to do that. And this is what basically what the in silico thing said, was in Gulf War illness, if you could block the pro-inflammatory cytokine cascade long enough to reduce neuroinflammation, and then block the HPA axis long enough to force it to do an internal reboot, reset, that you could, if you did it in that time course, 1 and then 2, hypothetically reboot the whole system back to normal. Sounded crazy. But in Gulf War illness, we have an animal model that's darn good. We took our dynamic modeling model, and we looked at all the animal models that are out there for Gulf War illness. And we actually had people do exercise challenges on the animals and do the dynamic modeling in the animals and found the best fit. And we picked that model as our testing model. And then we aged that animal out after we induced the illness, the equivalent of 10 years of illness. And then we did this. And we rebooted, we brought neuroinflammation down about 50%, which was enough. And then we threw the mifepristone dose in there and a single dose of mifepristone. And we rebooted those animals back to normal. The autonomic function normalized, their immune function normalized, their neuroendocrine balance all normalized. And we can challenge these animals and get normal dynamic models out of them. So we were over the moon that we were successful.